There we go.
So welcome everyone to another Tuesday talk. We have a very special guest, the CPS department head, Lindsay. We're very happy to have her as our last Tuesday of the fall semester. So I'll let her get right into it, and we're looking forward to the talk.
Good. Um, all right, so the title is Learning to Read the Rocks, and I thought I would tell you a little bit about what's going on in my lab right now, just a tiny bit, and then sort of go back in time and take you on a little bit of a personal journey, and how I learned to read the rocks or whatever, and then we'll come back again to my research sort of right at my kind of current research at the very end, but just in a fairly shallow way. I thought it'd be more interesting to do this than to tell you all about the ins and outs of a lot of the work that my students are doing actually right now. Okay, so what I do, it's tectonic geomorphology, and then we often throw in that landscape evolution part. So tectonics, so on the left here, I've got this map of the tectonic plates, and then geomorphology. And geomorphology is the shape of the landscape, but what we're looking at in tectonic geomorphology is how plate tectonics interacts with forces that shape the landscape. So rivers and glaciers and sometimes wind erosion, actually. So the rain is meant to sort of represent that wearing down of the landscape. So tectonics builds it up, climate through rivers, glaciers, and wind tears it back down, and then you end up with really spectacular topography like this image down at the bottom at the end of it. And right now in my research group, I have 6 people. So I have 2 postdocs, Alex Tai, who started in January. He went in the field in February, and then COVID hit, and he moved back to Michigan. So we've been doing everything remotely ever since. But he's doing work in Argentina. So he did a bit of field work there, and is working on sort of the geodynamic history of the Puna Plateau. And then Monica Gionabucci, I don't have a photo of her, but she is working on paleoseismology in Ontario. So she was intending to do fieldwork during the summer of 2020, but we weren't able to do that, obviously, because of COVID. But she's looking at figuring out a way. One of the problems in Ontario of trying to find active faults is that there's exposed bedrock and it's been etched out by glacial erosion. So everywhere you look, there's linear features, that are related to some of the ancient history, billion-year-old history of the Grenville origin. And what we're trying to see is what's happened in the last couple 100,000 years. And so sort of untangling this pre-existing history from what's active today is difficult. So she's trying to do that all remotely right now. And then I have 3 PhD students. I'm sure you guys all know Mitchell and Erin. So Erin is the most senior. She's graduating probably in March, and she's working in Argentina. She does really interesting work. It's just outstanding work on looking at drainage reorganization and erosion rates. So it's very geomorphic on the geomorphic side of things. And then Mitchell McMillan is also graduating probably at the end of the summer, so relatively soon. And he's also doing amazing work, and it's very eclectic. So he has some work that's looking at wind erosion. He's also done some really beautiful geologic mapping, and he's trying to understand the structural history of part of the Puna Plateau in Argentina. And he's also doing some modeling. So he's writing numerical models. And then I also have Josh Wolpert. So he is somebody that you may see in the future. He's just started in the fall, but he didn't get his visa until like last week. So he was stuck in the US living with his parents in Manhattan until he got permission to cross the border. So he's coming in next, maybe even this week. Yeah, I think at the end of this week, he's actually physically arriving in Toronto. And he's going to be working on a new project in Nepal. So he's looking at how there's a sort of weird flat part of the Himalaya where it should be all very steep landscape, but there's this very low relief, high elevation area. So he's trying to understand the origin of that. So that's the group. Oh, and then I'm sorry, Anila. So Anila is, I think most of you know her. She's an undergraduate in our department, and she has been doing some work in Argentina, working with Alex Tai. So she's doing an ROP with him over the summer, and then she continued her work in the fall, looking at the deep, trying to use the sort of surface expression of this bedrock erosion surface to try to understand what the deep structure is of faults in the Sierras Pampeanas in Argentina. Okay, And then there, you know, the billing for this talk was I would also talk a little bit about teaching. And most of you probably know this because most of you have taken both of these classes, although not all of you. But yeah, so I used to teach 101 or 120 as it used to be called, and I really enjoyed that. But I don't know, change is good, and it's also a real pleasure for me to be able to teach upper year courses for a while. But I taught that for years, and now Sameka is taking it over this year, which I think will be fantastic. And Jess Slomka took it over last year. And then I also used to teach 202, and I love that and still do and miss it terribly. But same thing, it was sort of, you know, easier, maybe more important for me to teach these upper year courses in a rotation than it was for me to teach 202. So I now teach tectonics, ERS 302, and you guys again know this, but you know there's this the big part of it is this world building exercise where you create a world including the tectonic and geologic maps from scratch. And then ERS 402, advanced structural geology. So that is meant to be a follow-on from ERS 202. You can take it in your third or your fourth year. And it's it's sort of a flipped classroom. I don't do a lot of lecture. Instead, you do this portfolio where you take notes essentially outside and answer questions outside of class. And then in class, there's a lot of activities, including learning some software. And hopefully next time I teach it, it'll be in the new Earth Sciences labs, and we should actually have laptops that are set up there that we can use. It'll be a little bit easier than it was, you know, in the past. So I'm probably not teaching tectonic, they're alternate years, so I will not teach tectonics until 2022, 2023. It will probably be in the fall, but that's a little bit of a TBD. And then advanced structure will be taught next year. I'm guessing it's going to be in the fall, but it could be in the spring. Like I said at the beginning, it just depends on the balance of other courses that are being offered. So any questions on that stuff so far? Okay. You guys should feel free to interrupt me at any point. I hope that you know that.
I was just going to say, I was just thinking about it, and I think that myself and maybe Alessio might be the only two students who took every single course with you that year. 101,
Right.
202, 302, 402, and the Rocky Mountains field.
And the Rocky Mountain. That's right. I forgot to add that here. ERS 425.
Yeah.
Yeah. Yeah, which hopefully we'll offer again this fall. Yeah. Anyway, so I should have added that, the Rocky Mountains trip. Yeah, we are planning, like we've just put it in that. Oh, Christian too? Oh, nice. Good, perfect. Okay. All right, so now what I wanted to do was the area of the Himalayas as the Tibetan Plateau. Were you wondering where I was talking about Josh Wolpert, who's working in Nepal? Yeah. Yeah, it's in Nepal. And the idea is that we think that, you know, so it's interesting, like when you talk to different people, you get a different definition of the Tibetan Plateau. As, you know, tectonic geomorphologists, we tend to think of what we call the morphologic plateau. So it's the area of low, you know, low relief and high elevation. Geologists often talk about it though more in terms of like where the suture zone is, and you know, so they talk about, you know, what terrains are making it up. So they kind of put it in different places. But yeah, I think the fundamental idea is that the MCT, the main central thrust, in place this big slab of high-grade metamorphic rocks at a relatively low angle. And we think at that time there would have been a continuous low relief surface that went from Tibet all the way into Nepal. And then after that time, two things happened. One is that there was something called duplexing that happened between like modern Tibet and the part of Nepal that we're looking at, where these mountains kind of got pushed up from below because of duplexing. And then at the same time, like you had intense erosion coming in from the Indian side of things. And so we had this little part of, you know, high relief, high elevation, low relief stuff that was part of Tibet morphologically. But then it got cut off from Tibet by rise of the high Himalaya, and then it got incised by rivers coming up from India that kind of cut in all around it. And so now it's just this little kind of table that's sitting there by itself. It's not the only one. There's actually a couple of these little table-like features in the Himalaya. So I think it was in the Himalaya, not the modern Tibetan plateau, to answer your question. Cool. Okay. All right, so now I wanted to take you back in time a little bit. So geologic time, oops. So this is the geologic time scale with which you are all familiar, I am sure. And this is my geologic time scale. And so I was a kid, and then I went to school, and then I went to university, and then I went to grad school, and then I had a postdoc. And then I don't know if you guys know this, but I was at Ohio State for 4 years as a faculty member. So I was an assistant professor there before I came to UTM. And then this is UTM. I maybe put this presentation together a couple of years ago. So I'm not 41 anymore. I'm a few years older than that. Not many, but a few. But I guess, last time I gave this talk, I was in person and I actually had some rocks. So you're just gonna have to imagine, they're at my office. I don't have them here. And you obviously can't touch them because we're doing this remotely, but pretend that I have some little rock samples that tie into this. Okay, so I'm gonna start with this. This is what happened 64 million years ago when the dinosaurs met their end. And I don't know if you guys are familiar with this, have seen this photo or can guess where this is. This is Luis Alvarez here and this guy named Walter Alvarez here. Walter was a geologist at Berkeley. And these are the fossils that you would find below Walter Alvarez's hands. So these are the microfossils that are contained in the rocks. These are pelagic sedimentary rocks from a place in Italy. So they're little marine organisms that lived and died and settled down to the ocean floor and very, very slowly accumulated. And then the stuff up here, this is what these fossils look like. So you can see that they're much, much smaller. They're much more uniform. They have much less biodiversity, and they're actually much less dense. So this is a larger bulk sample that they had to take in order to get this density of fossils. So from below to above this boundary, you have a drastic reduction in the diversity of life, a reduction in the size of organisms, and a reduction in the abundance. And also, right where this guy's fingers are, there's this little bit of clay. And this is what it looks like if you look at position above and below the boundary. And this is iridium levels. And iridium can be erupted in volcanoes, but most of the time, the source for it, or in this case anyway, the source for it is extraterrestrial. It's through the impact of an asteroid with the Earth. So right in here, the levels of iridium spiked. So you guys have probably figured this out. This is the KT, Cretaceous Tertiary boundary, and it records the same events that led to the demise of the dinosaurs. So I had a sample. So I did my undergraduate work at a place called Carleton College in the US. It's a very small school, about, I think, an enrollment of 1,800. The geology department was the third largest department on campus when I was there. So we had a huge number of majors. That's pretty unusual. Usually geology is like 5 people a year. We had about 30 a year at Carleton. And our field camp was not in Whitefish Falls. Our field camp actually was in Italy. And so as part of my undergraduate work, I got to go see this site. I wish this was my picture, but I was actually at this site. This is the KT boundary at the most famous place where you can see it, the Gubbio section in Italy. And you can see it now. It's marked by this big groove, and that is a human-caused groove. That is all sorts of excited geologists and probably amateurs as well, who went in here and really wanted a piece of this stuff. And so they went in and sampled, so much so that they actually had to cover this thing over with fencing. Now, the fencing might also be to protect from rock falls, but I think it was at least partially. And this sign here basically says, don't collect. And right around the corner, there's a little cafe. And we went into that cafe and there's a book, and all these famous geologists have sort of signed, it's like a guest book essentially. And they've signed that they were there. So I have a sample of rocks from above and from below the KT boundary. And that was very meaningful for me in my undergraduate work. Okay, so that was at this time in Earth's history, and that was at this time in my personal timeline history. Okay, next, I went to graduate school. So I went to MIT and I worked with a guy named Clark Birchfield. He was not the most hands-on of advisors, super nice guy, very supportive, amazing geologist, but didn't pay a lot of attention to his students. So I ended up working with another guy named Callan Whipple, who was a geomorphologist. And so I got this amazing structure tectonics background from Clark Birchfield, and this amazing exposure to a very energetic group and a really excellent advising from Callan Whipple. and that shaped my tectonic geomorphology. So this is where I did my PhD work. This is not my photo, I wish, but this is a photo from my field area. This is in Yunnan province in southwest China, quite mountainous. But as you can see, there is a little bit of anthropogenic modification of the landscape. These are all obviously rice, mostly all rice terraces. And you can see, you probably cannot see very much rock. There is very little rock exposed. You know, most often it was actually exposed along rivers, including the Red River, which is a really large river. But yeah, there was a lot of sort of wading through the mud. It was hot, and there were spiders. We saw a king cobra one day in a drainage ditch in the field. A lot of walking on little muddy trails. It was really interesting place to do field work, and a lot of landsliding, which kind of messed things up for us too. This is kind of, I guess, the crowning achievement of my PhD work. This was the result of probably 3 field seasons of work. It doesn't look like much, and I gotta say, when I look at these colors, I'm horrified. This is an ugly map. I would not make a map that looks like this today, but this was a while ago. We didn't have a lot of topographic data. You know, this was I started grad school in '98. GPS, we'd actually, my first field season, I didn't have a GPS. So someone asked me to find the location of some samples that I had collected, and I looked in my field book and I was like, why am I missing the GPS coordinates for this site? And it was because I had forgotten that I didn't have a GPS. And so I actually had to go to a map, topographic map, and then figure out where it was on Google Earth today, you know, and get the coordinates that way. So anyway, this represented me inching my way along the river and the roads here and mapping these units. And these purple rocks over here, the Alishan Shear Zone. So this is one of the major strike slip faults in Asia. It was active until about 17 million years ago in a left lateral sense, and it accommodated the extrusion of the stuff up here to the southeast out of the way of the India-Asia collision. Sorry, other way around, the stuff down here. And then it got reversed along this thing right here, this little black line, which is the Red River Fault. And that's an active fault today. Not the most active, there's actually a whole set of faults that come in this direction that are more important. Anyway, but this is what I did. I mapped for my thesis. Here's some random field photos. So here we are with some of my colleagues and my field assistant. Sometimes we had trouble with our cars. Oh, and notice that this is a slide. This is also before digital cameras. So I took all my photos on slide film and then scanned them later. Here's another hazard of doing field work, trying to cross bridges. We didn't try to cross this one, but that's the Red River, and we were dealing with conditions like this quite a bit. And then we actually ended up buying a canoe. So this was a collapsible canoe. And it packed up into a big bag, and we flew that over, and then would go up and down the river in the canoe. And it was actually a good way to get to Outcrop, except for one time where we capsized and ended up getting swept through some rapids, and there was some drama, but we all survived, and it was fine in the end. Good bonding experience. And these are some of the people I worked with. That was really so Lao Chen was a geologist a colleague in Yunnan. This was our driver, Lao Ko. This was Michael Stewart, one of my field assistants, Josh Feinberg, one of my field assistants. Michael lives in a little cabin in Alaska. Josh is a professor at Minnesota doing paleomag. And then Sinan Akshiz was another graduate student, and he does paleoseismology on the San Andreas Fault now. And he's at UC Irvine, I think. And we're right here. This is called the Tiger Leaping Gorge. This is the Yangtze River, and it's incredible cataract. Like you would just die. There's a story about, somebody was trying to build a vessel, he wanted to, paddle the entire Yangtze. And so he built this like closed vessel, and he put a dog in it and sent him down the river to see if the dog would survive to the other end of these rapids. And the dog and the vessel were never seen again. So, so no human has been through here. Okay. So that was my, so the rocks were about this age. I mean, it's actually a bit more of a span, but they were sort of Miocene in age, and that was my grad school time. Okay. Next, I did a postdoc, and I went to Germany for my postdoc. It was a good opportunity to just get out of the country for a while, get used to, exposed to European geologists in a more intense way than I would, staying in North America. And it's also a really excellent place for doing what I do, tectonic geomorphology. And so I ended up working through that project in South America, and I've been working there ever since. So this ended up being very profound. So I've about 15 years I've been working there, and I've probably had 20 trips to Argentina. And we were looking at this thing right here. This is the Puna Plateau here in the south and the Altiplano Plateau in the north. And you can see it's both high, but it's also quite wide, right? It's a couple 400 kilometers or so across. And so the question is, how did it form? And we spent a lot of time there thinking about geodynamic questions. So for example, there's this idea that as you thicken the crust, you're also thickening the lithosphere, and it becomes so thick that it can actually becomes gravitationally unstable, and it starts to sink and drip away. And this is actually my drawing, and it's to scale. So I spent a lot of time investigating that, doing lots of amazing field work. So there's lots of volcanoes. A lot of this reddish stuff is little cinder cones, basaltic cinder cones that weathers red. I'm on just a hill. Anyway, and that's our two vehicles down there at the bottom. So obviously we're driving off road. It's super remote. And surprisingly, there's very little vegetation, but the outcrop is terrible because everything is weathered. It's like just sort of frost shattered. And so you get this colluvium, this like just stuff, at the top that sort of smears down the hillside. So yeah, it's surprisingly hard to map despite like 100% exposure or no vegetation cover. But we do a lot of mapping. Like that is my favorite thing to do in life. So I've mentioned wind erosion a couple of times. This is Juan Palavecino. He was one of our Argentine field assistants. And look at these boulders. They have been blasted by the wind. The wind is very, unidirectional. It's always coming from the northwest, and it just has blasted away these rocks over time. There are places where just sort of pebbles, like low stuff on the ground, has been blasted, and it, those things that you drive over when you're like leaving a parking garage and you can drive one way, but if you drive the other way, it'll pop your tires. It's like that because they've been sort of sculpted by the wind. And I remember one time driving downwind and I was thinking, oh my God, like when we turn around, all these little rocks are going to be pointing right at our tires. And it was fine when we got out. But anyway, we spent a lot of time driving in the middle of nowhere. I mean, if you look in this direction, there is nothing for 100 kilometers probably. Yet we worked in there, just by driving off road. Okay, and so that work, or that geology, so it's actually a bit older, but one of the most recent dripping events we think was right about here. Actually, I should move it right there to the Messinian. And this was that time of my life. And then I went to Ohio, and we can kind of skip over that because, wasn't that great. And then I moved to Toronto. And this is what, I don't know if this is the best image of it, but, this is the first time that I encountered old rocks. I really had spent most of my time working in very, very young rocks. And, so here we are in Ontario, and this gray blob of stuff that's really old. And the rock I would be showing you if if we were in person, it was my little chunk of the Acasta gneiss. I have a little piece of it. It's my most prized rock possession because the Acasta gneiss is the oldest known rock on the planet, and it's 4.01 billion years old. It looks something like this. Actually, this is the Acasta gneiss. Oh, and is that sandbarring? No, it's not. Anyway, so when I moved here, yeah, I was exposed to these old rocks for the first time, and I have this. I probably told some of you this because I use this example quite often. But I went on this field trip early on, and I remember being shocked. It was like this, road cut in Ontario, right, where it's just a bunch of like straight gneiss, and you walk down the outcrop and it's just more straight gneiss, and it's dipping 45 degrees in some direction, and it's just a bunch of gneiss. It doesn't say a lot to me given the kind of geology that I work on, but anyway, and I was overhearing this conversation, and they were saying that one end of the outcrop was 3.1 and the other end was 3.2. I was like, 3.1 what? 3.2 what? And it was billion. 3.1 billion years old and 3.2 billion years old. So between one end of the outcrop and the other, where I couldn't see a single difference, there was 100 million years in age difference. 100 million years, right? Like you've built the Himalaya and you built the Andes in less time than that. So everything I did, in my entire career fit in less than, half of that outcrop in terms of time. So I'm simplifying the structural geology of that outcrop a bit, I'm sure, but anyway, interesting stuff. So it was a really nice and interesting and new sort of exposure. So I'm going to put a little star down here in the Archean. Actually, that's no, that's fine. I can't read the numbers. And then that's me here. when I first started in my current position. Okay, so I think I'm basically at the, let me just check. Okay, just a few more, yeah, a few more fun photos, I hope. So just to sort of summarize a little bit, because you've seen a bit of a scattering of what I do. So just kind of come back to that slide I had at the beginning about what is tectonic geomorphology and landscape evolution. So we're looking at the constructive forces of tectonics and the destructive forces of erosion. And I'm going to put two things above the kind of tectonics line because they have more to do with tectonics. So one of the things we look at is plateau geodynamics. So things like lithospheric foundering. So are there drips that detach from the bottom of the crust? Extensional collapse. So with our plateaus collapsing under their own weight. Lower crustal flow. So is the lower part of the crust so weak and squishy that it can actually get forced out into the surrounding areas? And then plateau uplift. So how do plateaus get built over time? And then also on the tectonic side, I've done quite a bit of work on what we call neotectonic. So measuring fault slip rates. Jeremy Raimondo, if you guys remember him, he did that kind of work. Paleoseismology. So my current postdoc, Monica Gionabucci, is working on that, and then hazards. So this is the tectonic-y stuff. And then there's the erosion stuff. It's also related to climate. So I'd say most of my work on this side of the equation has to do with river erosion, because rivers are the drivers of landscape evolution. They do the most work in the most settings. So looking at, trying to get quantitative measures of tectonic uplift rates by looking at geomorphic features like the shape of basins or the shape of rivers, how rivers reorganize themselves in response to pushes by tectonics, measuring erosion rates. I've also done some work on wind erosion, just a little bit. Mitchell's done most of this, but super interesting stuff looking at the impact of wind on the landscape. It's pretty rare that you have a region that's windy enough and dry enough, though, for this to make a big impact. And then also glacial erosion. This is also quite restricted. It's only in the highest mountains at at higher latitudes. But there's fascinating stuff here around how glaciers can kind of preferentially act on the landscape at a certain elevation, and that elevation is determined by climate. So, okay. And then I just want to close with a couple more field shots, just random, that are kind of fun. So this is me doing structural geology in the field with my colleague, Ed Sobel. This is in Argentina with my like tool belt and stuff. And then this is me riding a camel in the Pamir Mountains because we were collecting samples there for thermochronology. And we should not have ridden. We should have just walked because it was incredibly uncomfortable. But they certainly were helpful for carrying out our samples. And then I think this is the very last one. Yeah, the very last thing I just wanted to acknowledge is that like everyone here, like everyone you ever meet, there's more to me than my research. And I would say the most important thing to me in my life is that I'm a mother to two small girls. You've met some of you have met these girls in the past, but this is Riley and Brenna last fall. So Riley is 8. Last night, we watched the Faxis Gemini. We watched the presentation that from the tectonics class yesterday. I watched it with Riley, and she was so troubled by why an asteroid impact could stop a planet from spinning. So she's thinking about big stuff these days, and she's actually wearing these leggings today, as it turns out. And then this is Brenna, who's 5.5. She's an SK right now, and she doesn't think such profound stuff yet, but I'm sure she will someday. So that is the most important thing. I love the rocks, but I love these girls more. Okay, and that is the presentation.
Thank you, Lindsay. That was amazing.
Good.
If anyone has any questions, you can unmute your mic or ask them in the chat if you're not comfortable.
Yeah, about anything. If you have questions about the department or university or anything, I'm happy to talk about anything for another 10 minutes or so.
Yeah, I got one. Just considering you've been working in South America for 15 years or so, how long for the foreseeable future do you see yourself working there? And are there any other projects around the world that you'd be interested in taking on, like subject-wise, aside from art and the plateau and such?
Yeah, it's a great question. I mean, we're always thinking about what's next, in our research. for a lot of years, the sort of unifying theme. So, I mean, to be honest, a lot of times research opportunities just sort of approach you. So I recently had conversations with someone who works in Trinidad because, you know, there's a connection. Ed Spooner ran a trip there a couple of years ago and so on. So there's a possibility that I would start working there just because that opportunity presented itself. So sometimes that just happens, right? But the most unifying theme for my research for the last, I guess since my PhD, has been this idea of plateau stuff. So plateau geodynamics or climate tectonic interactions or erosion rates on the margins of plateaus or the interior of plateaus. And that because of that, you have to work, and there's not that many plateaus on the planet, right? So I've done work in China, in both southwestern and in western China. I've got this new project in Nepal that all surrounds the Tibetan Plateau. I've been working in Argentina on the Puna Plateau, and then I've also, I didn't mention it because it was sort of short-lived, but I've got some work in Turkey as well on the Central Anatolian Plateau. But yeah, I think moving forward, I'm quite interested in, I'm interested in moving away from plateaus and looking at landscape dynamics a little bit more generally, and particularly drainage reorganization and this using looking at the landscape to measure tectonic uplift rates. And I'm also interested in developing field sites that are a little closer to home. It seems quite wise, you know, given the current circumstances. So I've been thinking about a project in the Canadian Rockies actually as well. And I've got this project with Monica in Ontario. So I foresee continuing to work in Argentina. There is always more to do there. I think when you get to know an area very well, you always see that there's more stuff that can be done, but I'm interested in expanding a bit and working in Canada as well.
That's awesome. Thank you, Lindsay. Great answer. Actually, yeah, you said it's open-ended questions. Any updates on the lab over here?
Yeah, apparently no, I don't know. So you guys know that they were almost built, and then there was some kind of flooding, and they weren't sure what the origin of the flooding was, and there's some damage to the floor. They were working on it again. I had Merrick, our business manager, just checked on it. So they were working on it again, and I think they were repairing the leak, but we don't have they have not been pursuing it aggressively, I think, because we're not going to be back in that space for a long time. So no, I don't have an update beyond their work. They're doing some work.
I'm just curious about that because I've been going to campus once a week to study just to get out of the apartment, and I check there almost every week to see if they're working. There's not been one time that I've seen any progress. It looks exactly the same from the start of the term.
That's good to know. Okay.
But then you look outside just north of, I think, North Davis, and they're building that. I guess it's a new science building.
Yeah, the new science building.
And that's moving fast. Like
Yeah.
that's moving fast. So I just don't understand why they're just putting that off to the side.
Yeah, that's a good question. You know, I think one of the things I've heard about renovations for our buildings is that it's a lot easier to get someone to build a building than it is to do a small job in a lab. That there's so much demand for construction work that, you know, they don't want to bother with this small job. So we've actually had a lot of trouble with that. So it might be that, and it's the tail end of this project. It's some, what do they call it? Deficiencies, you know, that they're working on. So the contractor's probably not very enthusiastic and has moved on to other work.
Yeah.
But I mean, to be fair, I don't think we've been pushing on it too much either. Like if we were calling facilities every day, you know, about it, but it's hard to do that because we can't say that we need it, you know, right now. So I don't know. Anyway. That's interesting though. But yeah, the new science building, I've heard it's 6 months ahead of schedule, which
That's
is
insane.
Yeah.
For construction projects.
It is. Yeah. Yeah.
I had a question, Lindsay.
Uh-huh.
What do you look for in graduate students? How do you pick your graduate students?
Yeah, that's a really good question. I think that the way the way that they approach me initially is important. So there's always a letter, an email, I mean, and you know, they'll include a CV, or should. And you know, I want the letter to be tailored, right? So if it says "Dear Sir" or "Madam," or if it talks about their interests in, you know, metamorphic petrology, then I know that they're not interested in working it with me. And usually I'll send a polite when I'm really busy, I don't bother to respond. But I, in theory, I like to be kind and respond to all of those emails. And I'll just say, sorry, I'm looking for students with, different backgrounds. But if a student seems like they're a better fit, or they've done some research, so they actually know what I'm doing, and I can see from their background why they would be interested in working with me, then we'll sometimes have a Zoom conversation or a phone call. And I want to know why they're interested in pursuing a PhD or a master's. Usually I take PhD students. I can see my camera's blurry. Hang on. Hopefully that fixed it. Yeah. So I want to, I don't want to hear for the student why they think, I don't mind this, but I don't really want to hear why they think grad school will be good for them, because it's kind of like, well, that's great, but I really want you to like contribute to my group, right? And this isn't, not doing this for, out of charity, because, and I also don't want to hear something like, well, when I ask, why do you want to do graduate school? I don't want to hear, well, I kind of, an answer that amounts to, that no one would ever say this, but I don't want to hear an answer that amounts to, well, I didn't know what else to do, or it seemed like the next step, right? So I really want to know that someone clearly wants to go to graduate school, that they have, that's part of their plan, and that they are going to have something to contribute to my group. And I'm also looking for background, and it doesn't have to be a specific background, but if they've taken some classes in structure, geomorphology, some GIS background, and then field work, like I want to know that they've spent some time in the field, looking at real rocks. So I think that's essentially what I look for.
I have a question on top of that. Do you prioritize undergrads with publications?
If I see a publication from an undergrad that is really impressive, it's very hard to do. But I don't think if you don't have a publication that I look less favorably on a student. A lot of that is about having the right circumstances, having the right supervisor to work with as an undergrad, having a supervisor who recognizes and supports your work and pushes it through to publication. And then just like having a project that works out, because you have very short timelines as an undergraduate to make a project work. And so it's really hard to do. So yeah, I mean, if I see one, it's amazing, but if I don't, I'm not concerned, right? Yeah, and it's pretty rare to see them.
Thank you. I was just curious.
Oh, although I would say, yeah, shout out to Reese, exactly. Yeah, Reese was amazing. If I have students who have a master's degree already, I am looking for publications there. And it doesn't have to be out, but it needs to be real, not like, yeah. So, the advisor needs to say, oh yes, we're just working on finishing touches, or I need to see a draft or something. Like, it needs to be a real paper. Yeah.
Thank you.
Mm-hmm.
It is 12:50. I know you do have to go. If anyone has any other questions.
Yeah, I have time for one more question, I think.
How often do you meet with your students?
Actually, before and after COVID, I meet once a week. So before COVID, we were meeting once a week, but all at the same time and in the same room, which I really liked. So I'd spend, and it was very flexible for me. It was perfect because I would just, when I'd finish with one student, I would just move to the next. So I kind of scheduled a block of time rather than individual meetings with each. So if it ran long or finished early, it was very flexible. And I liked it too, because everyone was hearing that conversation. So there was like better group understanding of what was going on. Post-COVID, I still have, it's like 45 minutes with each student, and I have them back to back. So for me, it feels back to back, but they're not, they're not getting exposed to each other's work as much. And then my postdoc, Alex, has been organizing a weekly meeting with just my graduate students. So they have a weekly meeting where they talk to each other, which is good. But yeah, once a week. I find that's about enough. Like, I don't want to, and then there's also email interaction. So if they send me a draft or something, I'm interacting that way. But yeah, it seems like it works fairly well.
I just asked because I'm starting my graduate studies, right? And in the age of COVID, and for me to be starting this from home and not seeing anybody on a regular basis, and even my supervisor, it just feels strange. So,
I mean,
all my communications are email, and I've met with Melissa, I think twice now, maybe 3 times, and it's just weird not to have that regular interaction. But
yeah, I mean,
this is getting started.
Yeah, especially, yeah, exactly. No, I mean, it's incredibly isolating, this thing that we're all going through. It's yeah, that's all I have to say. It's awful, right? Yeah, so I'm sorry to hear that. So I mean, maybe there's a way to organize a group meeting or something like that, and have a journal club, read a paper every week or something like that. Yeah. Okay.
Yeah, it hasn't been horrible. It's just been different,
Yeah.
I think if I had already started and was well on my way in my project, it would have been
Mm-hmm.
not so tough of a transition, but just getting
Yeah.
started, it was
Yeah.
challenging.
Yeah. Interesting. I have to say, if you've only met with her 2 or 3 times, that sounds like a little bit like not quite enough.
Yeah,
Mark,
that's
how often?
the way it feels to me. So
Yeah. Mark, how often do you meet with your students?
So it really depends on their year of study as well for me. So this for COVID, sorry, so COVID specifically. Pre-COVID, I was exactly like Lindsay. We actually had our office times at the exact same time. It's just different parts of the laboratory. So I'd be sitting around the table, and Lindsay would be in the back, but we'd be doing very similar things, getting our group together once a week about. During COVID, most of my attention's been mostly on my very introductory students. And so those who are in their first and second year, those who are about to go through their comprehensive or their thesis proposal defense, which is a really big deal for graduate school, especially in PhD. So those individuals I'll see once to twice a week. My senior PhDs, so those who are about to graduate like Dan and Katie, I see them when they want to. So that'll often be some weeks I'll see them 3 or 4 times because we're so close to getting a paper done and we're sending it back and forth between us. Other times it might be 3 or 4 weeks before I see them. And I might just get an email being like, look, I'm sorry, I've been reading. I didn't want to interrupt you. I was like, yeah, just keep doing what you're doing. Keep working on your thing. We don't need to meet every week unless it's a necessity. But early stage, I tend to meet quite a bit, just like Lindsay.
Yeah,
but COVID is hard, right? I have as Lindsay knows, I have an international student. So right now, she just came up to Toronto, and so she has to do the 2 weeks isolation. So international, new student, feels completely out of the loop, then ends up in a new city like Toronto, can't do anything, can't go anywhere, doesn't know anybody, and has to stay in a hotel every night for 2 weeks. It's been hard. It's been really, really hard to keep that dynamic, to keep the student and so for instance, my lab, one of my students decided we're going to play Among Us, which is one of those cute little games. We're going to start playing that as a lab just to kind of get ourselves seeing each other again, which was what we normally did during lab time. But with COVID, it's just everyone's busy and everyone's having a really hard time meeting up.
Yeah. And Christian, your question or your comment about unpublished graduate work being a red flag. Yeah, Mark, you're commenting too. I mean, I think it is yeah, it's hard to say. I agree. It depends on the circumstances, but I mean, ideally, and it depends on probably the country a little bit too, where they're coming from, but usually a master's thesis should result in a publication. So maybe not a red flag, but like a, I don't know, pink flag or something where you'd want to investigate further.
It's definitely a question. I would say it's like, oh, is your master's thesis coming out for publication? Will be one of the questions I would ask. And it's like, oh no, I'm not publishing it. Then I'd be like, okay, that's strange. So it depends also on the response, right? If it's like, yeah, it's coming, or oh, I really needed to collect some more data. It's like, okay, those are all completely valid reasons as to why the publication might not be set, especially if you're doing a 1-year master's. But if I don't get a sense that the idea of publishing is even in their heads, then to me that's a red flag. So it doesn't matter on having the master's, it's what's your mentality associated with that master's.
Well, I hate to do this, but I should go because, like I said, I have another uncomfortable meeting coming up. I need to gather my thoughts for that.
Thank you.
Not about anything
Lindsay.
interscience. Yeah, no problem. Thank you so much for inviting me. It was really fun. It was nice to see you all.
It was great having you. It was a great talk, and we really appreciate the time that you took to come and present.
No problem. My pleasure.
Thank you.